me talk about this. Such an interrupter. Let me show you this problem I just got a question about. Oops, somebody else chatted something. Oh shit, all right. Yes, it is okay to have an XY table. The thing I want you to realize though is some of you guys love decimals a little too much, but this is a definite example of a place where the decimal sucks. So a much better way to write this is like this, right? And then you can write it. Let me see if you guys are cool with this, like that. I don't know if that helps. I don't know, that might help a little bit. So you don't really need a calculator. Or did you really need to do all that? No, but so what? You can still write it like that. You can pick your favorite little anchor points that I use. The main point about this is trying to get us ready for logarithms because it wants us, well, no, it's not quite logarithms yet. Somewhere you have to graph the inverse. This is just a reflection. I don't know if that really helped at all, but yeah, you could just use a table. This way, if you do it this way, you don't really need a calculator. You should be able to do that. How you guys do? Is that all right? So even before you do anything, can somebody tell me, so here's a normal exponential, right? There's a normal exponential. Bam, there it is. How is this going to differ from the normal exponential? Focus on the negative sign. So what's that negative sign there going to do? Oh, I got a chat. Let's see. You guys are all being shy today. Oh, it's another question for later. All right, let's focus on this right now. Somebody help me out. That negative right there. So if I had, here's 2 to the x. If I had 2 to the negative x, what would that do to the picture?
Would it flip it?
Yes. I need a little more specific.
It would flip it over the y-axis?
Over the y-axis. Big S. Right? So it would flip it so it'd be like this. Oops, shit. It basically makes it become decay, right? Pretend like that's a better drawing. And then what does this one do?
Flips it over the x-axis?
Yes. So now it's going to look like this. So that should basically have this shape. And then it asks you to graph the reflection about the y-axis. Okay. But to me, I like, especially when it's something like 1/4. I mean, it just makes it better to make the base 4. You don't have to, but why not? The big thing there is I hate it when people make this like -8. We talked about that, right? So you can't make this -8 because that takes precedence in the order of operations. You can't just break that. Yeah, I like it. So be really careful. Is that all right for that one? All right, somebody else had a question. I always hate that when the calculator does something you don't want it to do. Let me see. 51 and 54 of 6-1. I'm going to clear all my chicken scratch. All right, 6-1. Oh, crap. I didn't clear it, did I? What happened? Why are you still there? You do what I want you to. There we go. All right. Let's see. 51. Oh, okay, good. All right. So I didn't know. All right. So let me show you this. I don't mind showing you this, although we did talk about another section of homework where you really had to do this by hand. But this one says use a graphing calculator to find the equation of an exponential function. So let me show you this. This is really kind of cool. I'm going to stop sharing and share my calculator, which means I got to wake it up. So hold on. Let me see. There you are. Okay, let me bring you over here just because, yeah. And then I can share. There we go. Okay, so here's something kind of nifty. I just want to show you if you go and you can put data. All right, so let me slow down. So if you hit stat, so this is really cool. Stay with me, stay with me. If you hit stat and you hit edit, and they've got all these steps in the book. Let me clear, I can clear these lists, clear. Let me just clear a couple of them. Or 3 of them, sure. Let it go, Jeff. There, that's fine over there. So now watch real quick. If I ask you to find the equation of the line that goes through 0, 1, and 2, 3, those 2 points. Now just think about it for a minute. 0, 1, that's the y-intercept. So B is 1. I already know what B is, don't I? What's the slope of that line going to be that goes through those 2 points? And by the way, I know this isn't the answer to the question. I'm working my way there. What's the, come on, you guys can do it. So this is x, y, x, y. How do you find the slope? Y2 minus y1 over x2 minus x1.
It'll be 1.
1, beautiful. So the equation of the line that goes through the points should be y equals x plus 1. Right? 1x plus 1. So now watch. If I do stat, oh, let's see if I remember. Yeah, calc. And then I go down to linear regression. See how it's got a line there? Then I could do quadratic. I could do cubic. I could do quartic. I could do natural log. So let's see if I do linear on L1, because that's where I put my x's and this is where I put my y's. Is that all right? Don't worry about the rest of this shit. Ax plus b, 1, 1, 1x plus 1. So it gives me that. So my 110 students and my math 90 students wish they knew about this shit, but oh well, they don't. Haha. So if you look at this list of things we're allowed to do, if you scroll down a little bit, there's exponential regression. So let's try an exponential regression on those points. There you go. So it would be 1.73 blah blah to the x. That would be the exponential function that fits those 2 points. So whatever your problem is, you put it in. Edit's how I give the calculator data. And then when I go to stat calc, now I can calculate stuff based on the data that I gave it. And they do have these steps in the book somewhere in that section. And you can see, I mean, it's really cool. I mean, I could do all these different things. Look what it does when I try to do this one. That's interesting, right? So I was going to try to do quadratic regression. I'll let you think about why that didn't work. How many, real quick, how many unknowns do I have for quadratic regression? I love this question because it's like, holy shit, Jeff, can you break each one of those words down? So what does a quadratic look like? What's the most basic form of a quadratic? Oh shit, I can't access your chat. Hold on. Where'd the chat go? Hello. I'm gonna stop sharing. 2, no. I don't know if that was from earlier. The most basic quadratic is ax squared plus bx plus c, right? Is that cool? How many unknowns are there? Not counting x, because x is already unknown. How many unknown things to define a function?
3.
3, I like it. So only giving it 2 points was not enough data. That's why it freaked out. Anyways, that's all on the side. I'm sorry. I went off a deep end there. Had nothing to do with this problem. And somehow I don't care. I still like talking about that shit. So that's how you do these. Just make sure you choose, so let me see, these guys here. So you're going to put in the list 1, you're going to put 0 and 3. In list 2, you're going to put 3 and 375, just like an XY table. And then you do that exponential thing that we just did. Is that all right? That's how to get it from the graphing calculator. Yeah, go ahead.
I kind of missed the part where you went from where you got the equation on the calculator. Like I got the first part and then the second part, like, I don't know.
So when I do stat calc, which one was it? Number 0. So here's the form of it. A times B to the X. A is 1 and B is 1.732, blah, blah.
Okay, got it. Thank you.
Sure. So you just got to fill in. So if I gave it, oh man, Jeff, let me see. Oh, Jeff, let me see. Get over there. Let me see if I can give it. Let's see if this works. It should. Well, let's find out, Jeff. These could be touchy. This will work. It's just, I wonder if it's going to be really gross. Oh, not too bad. Look at that. That's beautiful. But you can see it gives you the form, so you can see it needs 3 pieces of information for a quadratic, but it only needs 2 for an exponential because there's only 2 unknowns, the coefficient and the base. At least for the form that it uses, yeah. All right. Anything else from homework stuff?
Could you go over 60 and 57 of 6.1?
Where am I at? 6. Oh, yeah. So 60. Oh, this is good. All right. So I was just talking to somebody earlier about these. So I'm sorry, I assigned this and it kind of goes back to number 56. So you should really look through 56. So I can instead say, that's me being evil, making you 2 for the price of 1. Haha. Anyway. Let me try it this way. What it's saying there is what I'm going to end up with is a percentage that represents the actual amount that I earned in a year. So what is the formula for how much is in the account at the end of a year, compounding monthly? Oh shit, there's a lot of parts to my question. So the basic formula is P times 1, get a 1 in there, plus R over N to the NT, right? So monthly, of course, N is 12. R, I don't know P. Okay, so that's how much is in there after T years. So after 1 year, which is what this is based on, where did 1 year go? There it is. There would be P times 1 plus R over N to the N. Okay, that helped out a ton. Thanks, Jeff. Well, how much total money did I actually make? Money made. Not money mode, money made. So if I had $10,000 in there and I make and then at the end of the year it's $10,300, how much money did I make?
300.
Yeah, $300. So this is the amount of money that's in there at the end of a year. How much was in there at the beginning? That's what P means, right? So if I take P away from this, won't that be how much money I actually made, just like you did, right? Okay, I like it. And then this is a percentage. So what does that represent as a percentage of where I started, which was, of course, P? I really love this problem. It's so evil. I love it. It's not evil, though. It really isn't. So how do I get, so if P is 20 and the amount I earned was 5, what percentage of the principal did I earn?
25.
How do I figure that out? What do you do? You got the right answer, but let everybody know what you did.
Do 5 divided by 20 times 100.
Yeah, kick ass, right? 5 out of 20. I mean, that's the basic idea of a percentage. So this basically wants to get what's the percentage of the actual money you made based on how much you started with. So this represents the amount that you made, And all I have left to do is to divide it by where I started with. All right, so I basically did the problem. And then number 60 is the same thing, just with an actually easier equation. So this compounding continuously is where E comes from. It means you make money on the money you make every instant of time, not every month, not every day, not every second, but every instant of time. Okay, I like it. Which, you know, if for example, a completely hypothetical, if you had somebody that wasn't paying much taxes, maybe they could use that money instead of put it in a bank, I don't know, and make a lot of money off of that. I don't know. Compounding continuously, who knows? It seems like something that would happen for the very rich. All right. I don't know if you guys pay attention to current events. Anything else from, oh, somebody's going to chat at me. Have I got myself in trouble? I totally am, yes. Yeah, I am a little bit. It's just too bad. We're beyond me being, anyway, I'm not here to indoctrinate anyone. I'm just here to hope to shit. But anyway, that's enough of that. Nobody's worn a red hat in my class yet, thank God. Oh, let me see. Only facts here. Oh boy, that's a scary thing even nowadays. I'm not sure what your facts are. Yes.
Oh, just so for like 57, since it's related to 56.
Yeah, the only difference with 57 is what? This was done monthly. That's why there's what here?
There's 12.
12. This one's done daily.
Mm-hmm. So
you go ahead. 365. Yeah, we do
365. I can't even do it.
You're doing leap years. It's okay. I think, yeah.
I'm struggling. It's okay.
You're fine. You're doing fine. These are weird. Whenever you see this word here at the beginning of something I assigned, that basically is another word for bonus. These are going to be difficult. That's what extensions means. It means let's go a little bit further and drive you insane. Or closer to insane if you're not there already. Okay.
Thank you.
Oh, somebody's chatting. Let's see if I got myself in trouble. Oh, okay. I'm not sure how to take that. So, all right. Okay, let's not go down that road. I don't want to open that up. I don't want to know if anything's true. All right, let me stop sharing. Anything else from homework stuff? Let me see. Okay. So let me point out a couple things on Canvas. Wherever my Canvas is. Shit, hold on. There it is. All right. So something else I put here. Shit. All right. If you go to modules, so I don't know if you guys have paid attention. This is kind of grown. There's my extra office hours. There's the calculator workshop from a while back. Here's some pre-calculus help sessions. I can't remember when I added this, but Steve Davis, he's going to be doing some pre-calc help sessions. So I don't know if you know Steve Davis, but he's a teacher at Grossmont. He's been teaching pre-calc for a long time. And then we have this. They finally made the Math Study Center more like what it used to be before we had to go online. So there's still the by appointment. So you can click here for the instructions how to make an appointment for a tutor. But then they got the drop-in. So if you, here's instructions. If you click on this link during their time of operation, you'll be put into like a greeting room, and the person will say, what help do you need? And depending on what you say, if you say pre-calculus, they'll put you in a certain breakout room where the tutor is all about pre-calculus in that room. So you'll be in a room with other students who are also in pre-calculus, so you can help each other out. You'll also have a tutor. There will be a sign-in sheet, just like there was in the Math Study Center also. You guys with me? Have you ever been to the Math Study Center? Anybody? Before COVID? Nobody? All right, it's free. Do you know about the Math Study Center? So when we were on campus, I would always take students on a tour of the campus. This is kind of sad to me. So do you know how much money it costs to get a tutor off of Craigslist or something? So if you go there, you can get a tutor in the laptop lab. I don't know what that means. For like $35 an hour or something insane, right? It's a lot of money. Also, you have a chance to die because it's Craigslist. So you could become the next Lifetime movie. I don't know. So Mass Study Center is free. It's free for all Gross 1 students. So why the hell not? Why wouldn't you? It makes no sense not to. So take a look at those links up on Canvas about tutoring and consider it. You can go there, work on stuff. If the tutor's not in the room, you can say, hey, has anybody done this kind of stuff before? Can you tell me? And then the tutor comes in, you can get help. It's not a bad, I'm not sure what's happening. I don't know what that means. You want your own murder doc. I'm not sure what Oh, I see. All right. I don't know where I was going. I had this whole thing about ER doctor murdering people. All right. Yes, Ahmed, save us, please. I'm sorry, I called you out. You have somebody has a question.
Yeah, it's me. For 5.6, how do we find the local behavior again?
So what the book focuses on with local behavior is for asymptotes, asymptotic behavior. So if you have a vertical asymptote somewhere. To me, I also consider it. Go ahead, sorry.
So we just put the asymptote? Or
you don't just put the asymptote, you have to be specific. So, for example, let me go to the board. Use some real world shit instead of this virtual crap. So if I had a hammer, no, if I had a function like where is there going to be a vertical asymptote?
+1.
Yes. And I don't know, the horizontal asymptote is going to be where? Just get that out of the way.
Y equals 0.
Yes. So and x equals 1. So really, the way to identify behavior, local behavior, I would consider the x-intercepts too, but the book focuses on what's the behavior at the asymptotes. So as x approaches 1 from below, you don't even have to graph this, to be honest, but there's just the graph. I'm not even going to graph the function. As x approaches 1 from below, does anyone remember what we were doing? So if you put a number that is just below 1 in there, so you know that if you're slamming up this way, you're slamming down that way, right? As x goes to 1 from the left, let me say it like that. So if I put in there -0.5, will this end up being positive or negative? It's not that big of a question, right? Because no matter what the shit I put in there, what am I going to do to it?
Positive.
Square it. So then that's going to come out
Positive.
positive. So it seems like whatever I put in as I approach this, now, of course, as I get really close to 1, 0.99, 0.999, that becomes 1/100th, 1,000th squared. So that's getting stupid big, positive. Then the exact thing, same thing's going to happen from the other side. So that's the consideration. So if I throw in there, let me do this. Let me change this function a little bit. Let me give it one more. You need to put an X in there, Jeff. There you go, buddy. 1, 2, 3, 4. Okay, my scale sucks, but it's too bad. So this one would be as X goes to 4 from below and above. We can do this. So as I put things in that are below 4, what's this come out to be, positive or negative? If anything's below 4, what does this come out to be?
Negative.
Say it one more time.
Negative.
Negative. I like it.
Okay.
So if this would be like, let's make a different problem. So yeah, so this would come out to be negative infinity. And if I put it for a little bit above 4, it's going to come out to be positive. So I can't remember which section that was. Where was that? You said it was
5.6.
5.6. Where was that local? Which question are you looking at?
25 and 28.
Yeah, cool. I like it. So 25 is going to be nice and straightforward. Let me start with a function. So if I had, for example, let me get a function with all the parts in it to begin with, so it doesn't get all freaked out. So no matter what, this piece is going to be positive unless it's -3, of course, right? So there's vertical asymptote at 2 and -3. So I need to have a pair for each. So like as x goes to 2 from below and as x goes to 2 from above. And I keep saying below and above, from the left, from the right. I have to figure out what this function does. And it really just depends on, as it get closer to 2 from the left of 2. So like, what if it's 1.9? What if it's 1.99? The outputs, and can you guys see how quick it is to see that's going to be negative? Because it's less than 2. So this is going to go to negative infinity. Let me see. I don't have enough faces to gauge reactions, but that's all right. Okay. And then the same thing with, you can do this side, and then the same thing with -3, you're going to have x goes to -3 from the left, and as x goes to -3 from the right, and you'll notice it's squared. So whatever this thing does, it does it the same on each side because it's multiplicity 2. All right. Is that cool? Is that all right?
So that's how you write local behavior?
Yes, this is how you write local behavior.
Okay.
I allow you to do end behavior. You can actually just draw a picture. But local behavior, I could probably let you get away with drawing a little picture, but I'd rather you get some practice with this notation, because this is going to morph into limit notation when you go into calculus, if you do go into calculus. So the more practice you get with what this means, the more you'll be ready for calculus.
Perfect, thanks.
Sure. All right. All right, let's see. Is that everybody? I think I got caught up. Yes. Where are we at? Okay, this is interesting. I'm very concerned. We have 18 people here, which I don't know if I'm happy, because that's just barely over half of us. That's concerning. Okay, that's for me to worry about. All right. So did I finish showing you? No, I didn't. I showed you the tutoring thing, but there's another thing I want to show you. All right, my computer is freaking out. Let's see. So if you go to modules, I had somebody suggest a practice quiz like we did before. So if you go down unit 3, unit 5, of course, unit 6, here's practice. And I went ahead and put it in unit 6 because it does end in chapter 6. So this is a practice sheet. I am hoping that tomorrow I can make a little video about this. Let me see somebody's. Oh, okay. All right. Do what you got to do. Well, let's see. Does that take me down below half? I think it does take me down below half. All right. So hopefully I'll put a video just like I did last time with these solutions. Okay. Shouldn't be too evil, I don't think. All right, so, oh, I also, well, I was going to show you this, but I'm just going to tell you, I am working on, there's 2 reasons for me to put out an updated homework sheet. One reason is because I only have part 1 up there currently, so eventually I have to put part 2 up there. And the other reason is because we're off track a little bit now based on my initial guess. Right, so I'm updating this, and as soon as I get it done, I will put it up on Canvas. And just to remind you guys, I think this has already been said a couple times, but we have the next quiz this coming Wednesday. And just to let you know, I currently have the next quiz after that set for the following Thursday, the 8th. I think I really want to keep it there. So, yeah, I have a really hard time meeting with the class after they took a quiz and not having the quiz done. So if they give the quiz on a Wednesday, my Thursday is insane, trying to finish grading. So if I give it to you on a Thursday, I got till Monday, maybe I could do it. Yeah, so as soon as I get that done, I'll put that up on Canvas. Anything else before we get back into where we left off? Nope, okay. Let me see. So what we're about to get into, so we just did graphs of logarithmic functions, and we even talked about how to find the domain of a logarithmic function. So let's see if we remember how to do that. And then I want to make sure that you understand why is it useful to know how to do that. So how do I find the domain of this function? What's interesting is, remember I did this last time. I said, if this had been the square root of 7x plus 5. Do you guys just remember how to find the domain of this? What do you set up? What's got to be true?
Does n equal 0?
Yeah, the inside has to be at least 0, right? So that's something we more or less have memorized because we know that otherwise we get complex solutions, right? Logarithms, I find that since we don't have as much practice with them in everyday life as we do with radicals, we have a lot more everyday. And when I say everyday, I mean more often, maybe not every day. But we know radicals and we have a better feel for them. You need to know this guy's graph anyway. So can somebody tell me one thing about the graph of a logarithm? Just any logarithm, what's the graph? What are some properties of it? An unshifted logarithm. Let me say that. What are some properties of it? Can anybody tell me, does it have an asymptote? And where will it be? If I graph a logarithm. Okay. What's the log an inverse of? Every log is an inverse of what kind of function?
Exponential function.
Yes, cool. And the exponential function, you certainly should know what that looks like by now. What does an exponential function look like? Can somebody? There you go. I see somebody doing it. All right. So that's exponential. So logarithm is going to be the inverse of that. So for a logarithm, it's going to look like that. So its domain goes from not quite 0, right? It can't be 0 because there's an asymptote there, to infinity. So if I remember the shape of a logarithm, that it starts not quite at 0 and goes forever, I remember what's got to be true. The inside of a log, the inputs of a log has to be greater than 0. It's a little more restrictive than a radical. And then you just solve that shit, right? So whatever's inside here, you just make it greater than 0 and solve it. So x will be greater than -5/7. Now, how does it help me? This is a really, really ugly one to graph, but what is one thing that does for me? Can somebody figure out, what does that do for me? What's one aspect of the graph of this that you know now for sure?
Slope?
No.
It's a vertical asymptote. Yeah,
Yes, yes. What about it?
that it's -5/7.
Yeah, yeah. So here the vertical asymptote is 0 because that kind of restricts the domain. It's kind of like the back wall of the domain. So if now I can start at -5/7, that's where the vertical asymptote is going to be. And then it's going to go like that. It's not enough to graph it, obviously. I can find an intercept, and that might be enough for a rough sketch, right? Okay, okay. I picked a really ugly one. I didn't mean to try to graph this sucker. Just wanted to find the domain, but that's the connection with, if I know the domain, I know where the asymptote goes. Okay, maybe. All right. So that's one thing. And then, of course, we've got all the regular shifts that could happen. Let's see. Did they get anything more interesting? No. I want to make sure I don't forget anybody. Yeah, I love how they make a big deal. I told you this before, so I really want you to understand, when we learned transformations, it didn't care what the function was. The book makes this huge deal of re-explaining to you all the shifts. So let's do an easier shift. So there's your basic log function. So if I have this, doesn't really matter. Sure, I'll make it log base 2 just because. Right. And let me show you, it's kind of key when you're going to do transformations, you want some anchor points, because the anchor points are what you're going to apply the transformations to, and then you're going to graph the shape back on top. So what are some anchor points for log base 2 of x? It's kind of the reverse of the anchor points for 2 to the x, because it's the inverse of this. So I could kind of do this backwards, to be honest. Log base 2 of what is -1? All right, I'm throwing a lot at you, but I don't care. How do you rewrite that? How do you rewrite?
Is it 2 to the power of -1?
That's going to be 1/2. And then what about 0? Well, 2 to the 0 is
0.
X 0.
Oh.
1.
1.
And then when I put a 1 in, 2 to the 1 is 2. So I could have done this the other way. I could have said, since this is log base 2, what makes sense to put in here is anything based on 2. Like 2 or 1 is good for any log, because it gives you 0, or 1 over the base because it gives you -1. All right. So those are my anchor points. So let me kind of pretend like I did that up here. So this is 1, this is 1/2, and this is -1, and this is 2, 1. My scale sucks, but 2. So now when I want to do these transformations, first off, what's the domain going to be? How do I figure out what that is?
Would it be 0 to infinity?
No, because it's not just x.
X plus
Go ahead.
1 minus 2 greater than 0, and then solve it.
Is it -1 to infinity?
Yes. What's inside the logarithm is this. So the only restriction is the thing that is inside the logarithm has to be greater than 0. That has nothing to do with it. Does that make sense? So if I had the square root of x minus 4, does this have anything to do with the domain? No, because it just cares about what's inside the radical. That's what has a restriction on it. Is that all right?
Gotcha. Understand.
All right. So then x greater than -1. But I could tell, now the reason this one I didn't even have to really do this is because I can tell from the shift. The shift is not so gross as the shift I had with 7x plus 5. That shift was much more going on. But this one I could tell from just the shift. What would these shifts be? What's this shift mean? What does this shift do?
To the left 1.
Yes, so I got left 1. And what's this shift?
Down 2.
Down 2. And so the book makes a huge deal out of those things like it's brand new, but we know better. It's old shit. So if I graph my base function, so I've got my 1/2 -1, I've got my 1, 0, and I've got my 2, 1. There's my base function. And then I shift each point I've got, I can shift left 1, down 2. This goes left 1, down 2. You can do it, Jeff. Where'd it go? And then what have I not done? You I did already. You left 1, down 2. And now my asymptote is going to be at -1 because it went left 1. So now it's going to look like, sure. So it got shifted back and down. Okay, maybe. So it's all the same steps, just a different function. The function doesn't matter. The shifts don't care what the function is. They affect it the same way. Okay, all right. Cool, I think that's everything. Yes. It's amazing. It's as if it's all brand new and it's old stuff for us. So what I want to do, I want to talk mostly tonight about something not graphical. Let's get away from graphs for a bit. So all right, maybe. I keep saying that logarithms are exponents because the answer to a logarithm is an exponent the base needs. So logs are exponents, but we're going to see tonight how that means that the properties of logarithms are the same as the properties of exponents. So, for example, what is this? So based on what I just said, what does this represent? What does that what does it represent? What's a log represent?
what power gives
Yeah. The power that
that
B needs to
B
become.
needs to M?
Yes, I love it. So you could just say it's a power, but I like it's more specifically the power that the base needs to become this. So let me just call it small m. So then this guy, I'm obviously going to call him small n. That's crazy. Just to have something there, right? So we know what that represents. So if I see b to the little n, what is that based on what I've written?
Capital N.
Capital N. And b to the little m is, of course,
Capital
capital N. Okay, I like it. I like it. So this is going to take a little bit of getting through the details. I need to get through the details, and then I'll show you the kind of hand-wavy way to look at it, right? The everyday kind of way to look at it. So now watch this. If I have log base b of the product of two things. So I see m sitting here. So this is for any log of any base of any product, right? So we're going to develop a rule, remarkably called the product rule. Holy shit. Based on if I have a log of a product of two things. I see a capital M. How can I rewrite that?
B to the little m.
B to the little m. I love it. And of course, capital N is b to the little n. All right, so everybody cool with what's happened? Nothing major has happened. Okay, I like it. I like it. And then what do I do when I multiply things with like bases? What can I do on the inside?
You add their.
I like it. Just like that, right? And now somebody has to be able to tell me exactly what the hell that is. What is that? What's the log base b of b to the m plus n? Why is that so easy?
They cancel each other out, so it's just M plus
Yes. Log base b and b to the power are inverses. Now remind me, what the hell is little m?
Log base b to the m.
Big ass m, that's right. And little n is log base b of big bass. Big bass? No big bass. Big ass n. So what really happened if I ignore all this middle shit? And see how, what's m? Anything. What's n? Anything. What's b? Anything that, anything that works within a log. Are you with me? So we just did something that's true for any numbers here that work in a logarithm. This is true, period. So here is the shortcut. What does it look like happens if I have a log of a product? It becomes the sum of the logs. And why does it make so much damn sense? You can see right in the middle of this, when I multiply two things with like bases, what do I do with the powers? I add the powers. What are logarithms? The powers. So what's the power when I multiply two things? Is the sum of the powers. That's the rule for logarithms. If I have a log of a product, it becomes the sum of the logs. That's just saying the product of two things with the same base, I'm going to add the powers. That's all it says.
So I have a question.
Yes,
So if they would have been dividing, would you subtract?
you got it. It's almost like I planted you out there. So one rule is the product rule. So I've got log base p of m times n. It's going to be log base p of m plus log base p of n. So remarkably enough, if I have log base p of m minus n, it's going to be log base p of m, not get out there, minus n. Yeah, m divided by n. Log base p of m minus log base p. Is my brain in my head? I don't know tonight. So the log of a product is going to be the sum of the logs. So as I add powers when I'm multiplying two things, when I'm dividing two things, I subtract the powers. That's almost too good to believe. Well, that's all right. Somebody just rejoined us. And now I want to focus on something that, well, let's see, I can work on it right here. I don't have much room anyway. What if I have log base b of m times m times m times m. In fact, let me write this first like this. You're gonna love this shit. M to the p. So that means log base b of m times m times m p times. Is that cool? Just using the definition of exponent. I think amazing. Okay. Stop for a minute. Is that because that's what freaking p power means? Is I have p m's multiplied. Let me stop for a minute. And then of course I can use this property over and over and over again. I got a bunch of products. So what would this would be log base b of m plus log base b of m plus how many times? How many times?
Infinity.
E times.
No, p times.
Oh,
There's
p
only
times, p
p
times.
I can have PMs that I can break out. So what does that become then? It becomes, if I have P of these guys, I can just write it like this, P of these guys. Becomes the plug. So this is actually one of the most important rules. We're going to see in just a minute. The log base b of something to its own power becomes the power times that. Because what do I do when I raise something to another power? I multiply the powers. Right? When I have something raised to a power and I raise that to a power, don't I multiply the powers? That is what this is saying. This is a power and that's a power. So what am I going to do to the powers? When I'm raising this to this power, I'm going to multiply the two powers together. So, just to give you a taste of what this does for us now. This guy is huge. What that allows me to do now, sorry, little dude, is I finally have, so if I have this equation, 5 to the x equals 142.9. Oh yeah, that's awesome. And I want to know the exact answer to that problem. There's a major issue there. If it was freaking 5x equals that, what would I do? What would I do?
Divide by 5.
5 by 5. If it was x to the 5th equals 142.9, what would I do?
Take the fifth root.
Holy shit. If it was 5 over, you know, I can keep going all day, but I just, until right now, we did not have a nice way to make that power come down in terms of logs that are on our calculator. I'm going to show you a different way here in a minute, but I want to start with this way, just because. All right, so watch. So I don't know if you guys are with me. If you look at your calculator, what logarithms do you see you have access to on the front face of it?
Just log of 10.
Yeah, log base 10, and you also have right below that.
Oh, what's that one called? Natural log?
Natural log, yeah, I like it. So I don't have to use log 5. I don't have a log 5 on the face of my calculator. But what I can do is this. It's a lot like what I would do if I have 5 cubed equals 14, 114, x, no, yeah. If I had x cubed, I would take the cube root of both sides because they would kill each other. So what I'm doing here is I need that x to come down. The only function I have that brings the power down is logs. Which log do I use? Most mathematicians use ln. And this is only one reason, but it's a good enough reason by itself. There are other reasons. We use ln because it's got less letters. It's got one less letter than log. So if I take the ln of both sides, have I done the same thing to both sides? Yes, and be really careful. I did not just multiply both sides by something, did I? If you solve this and you said, if you're saying, tell me how to solve, and you say multiply both sides by the cube roots, I'm gonna look at you funny. And I hope you would do the same thing if somebody said that. You're not being mean, it's just, wait a minute, think about that. You're taking the cube root of both sides. So I am taking the natural log of both sides. Why the shit do I do that? Because now what can I do with this?
Bring it down.
You bring it down. And then what do I do to get x by itself?
Divided by the ln.
This is x times this shit. I don't want that shit. And then whatever the hell, this is the exact answer right there. You can't get any more precise than this. And that is one thing students don't understand. If I ask you for the exact answer, it's this. Because anything else you give me is an estimation unless you write the decimal forever. Right? Now take a minute. Can you see what that is in your calculator?
A big ass number. Well, not that big. 3.083.
That's fine.
Okay.
Just that, 3.083? Yeah, it sounds about right. Because somebody tell me, what's 5 cubed? 5 times 5 times 125. So wouldn't 142.9 be 5 to the little more than 3? Makes complete sense, right? Hopefully. So you can very often estimate what the answer is going to be, but this is how I get the exact answer. And then anything you write here in decimals is the approximate answer because this is supposed to go forever. All right. Now something I want to build off of what we just did. I don't know if anybody else had a different way to solve this. The problem, of course, is, well, let me show you. Let me show you this kind of really cool thing. It's called the change of base. Can you see that color okay? I'm running out of working markers. Okay, that looks okay. Okay, so if I had to figure out what log base pi of 77 was, do I have that in my calculator? Do I have log base pi? Not that you know it. Interesting how I said it. So, going off of what we know, I want to be able to rewrite this in terms of some logarithm that I have on my calculator that I know where it is. So what is the answer to this? I love this. What's the answer? Do you know what the answer is? Do you know what the answer is? No, say no. Okay, so then what is it? We've learned from algebra. When I don't know what it is, I call it. Now, how do I rewrite this? Rewrite this in exponential form.
Pi x equals 77.
Yeah,
Pi
pi
x.
to the x equals 77. And now I can do what we did over there. Right? That's not going to be big enough time. So if I take natural log of both sides, I can bring the x down, and then I can divide. So here's what's so freaking cool. Do you guys see the connection between where these numbers were? Pi is on the bottom. Where was pi in the original problem?
On the
Was
bottom.
On the base.
So the base goes on the bottom, and that goes on the top. That's how I can rewrite it. So let's see. Can you kind of prove this to me? Can you approximate this? What is that approximately? I hate how the calculator opens a parenthesis for me when it doesn't even know I need it. Come on.
I got like 3.795.
Yes, we'll say approximately. That's good, Jeff. That's all right. 3.7. Yes, 9.5. We'll say roughly. So how would I kind of check this? Well, in order for that to be true, what's got to be true? Pi to that has to be 77. So now put in your calculator pi to the 3.795. It's not going to be exactly right because we approximated. And of course, you could just do it to what you got in the calculator, but what do you guys get when you do that?
About
71.92.
77, well, you should get 77.03.
Mm-hmm.
Yes.
I got something different.
Is it a little bit bigger than 77? Because we put something that's a little bit bigger than what this really is. So what does that mean? How could I rewrite without having to go through all this shit? What's the shortcut? Let me do the general formula. Log base who gives a shit of who gives a shit is equal to natural log of that over natural log of that. The base goes on the bottom. This dude goes on the top. Now let's see if you guys get this next step. Instead of using natural logs, could I not have just used log? And wouldn't that just basically be the same steps, except there would be logs here instead of natural logs? So this is also equal to log m over log b, which is just a neat, what do you call it? Byproduct of a property of logarithms. It's kind of nifty. So coming back, what was that problem we just did? I trust my brain. What was the problem we just did? Log base, what was it? Log base 5 of, what was the problem we just did over here? Log base 5 of, I think it was.
It was 142 point something.
142.9.
Okay. No, so it wasn't that. It was 5 to the x. That's probably what's going right. It was that. Okay. Couldn't I rewrite this in logarithmic form? Wouldn't this be log base 5 of 142.9 equals x? This is what I was wondering if anybody was thinking about doing. You guys see that 5 to the x equals this, 5 to the x equals that? You have to be able to go both ways. And now I know how to rewrite this. This would be ln of that with the base on the bottom. Isn't that exactly what we got a minute ago? Yes, I like it. So the whole thing we went through, we actually just did it in general. So now I can do it anywhere I see this shit. I can rewrite it like this and use the logs that are in the face of my calculator. Okay. I like it. You might, let me see if I forgot anybody. There's one little thing in here. Yeah, okay. Last thing I think I'll do, unless, well, I don't know what time. Is it overtime? No, it's not. Good. Okay. I think this will be the last thing. So coming back to the other properties of logarithms. So now we got the basic properties all down. Product rule, quotient rule, power rule, and now the change of base form. Right? If I see, you're dead, aren't you? I'm sorry, little dude. Gosh. Log base C of D times W over A. Can I break that up? So normally what I do is I break it across division. So what do I do when I'm dividing something by something else inside of a logarithm? How can I rewrite that?
It would be log D times W minus log C of A.
Yes. Okay, so the first thing I can break it up across is this thing divided by that thing. So that becomes log of this thing minus log of that thing, because I subtract powers when I'm dividing things with like bases. All right, I like it. And then of course I can break these up.
Log C of log D times log W.
No.
log C of D.
Oh,
plus
plus,
C of
yeah.
D.
I like it. Cool. So you got to be careful because sometimes I think parts of our brain just think it's some kind of distribution or something. That logs don't work like that, of course. It looks like it did something weird, but did it really make multiplication become addition? No. Right? Nowhere does it say D times W becomes D plus W. Log of this becomes log of that guy plus log of that guy. That's just a weird way logs work. Why do logs work like that? Because they are powers. I mean, on one level, that just kicks so much ass. The exponent rules are the same as the logarithm rules. That's so nice. Okay, maybe. So let's see, here's the last one. Did I already say it was the last one? Too bad. If I have this, can you go the other way around? What you got, Jeff? Sure, I like it. So here's the trick with this one. I mean, the first two aren't that bad, right? How do I rewrite ln of something minus ln of something else?
ln of x squared minus x divided by ln of x minus 1.
Be careful. No. See, that would be, if I said that ln of this minus ln of that equals ln of this divided by ln of that, that is magic. And I know right now there are students out there that are listening to me, even though there's not that many of you out there. And you're saying, that's what you're freaking saying, Jeff. That's exactly what you're, no, it isn't. This is subtraction, direct up became division. That basically almost never happens. So what really happens here is, when do I subtract powers? That's what logs are. When I'm dividing things. So what this says is the power on this is the difference in the power of this and the power on this. Because when I divide, I subtract the powers. Do you see the difference there? You got to be real careful. So this does not say subtraction becomes division. That's not what's happening. And of course, what happens over here? What sucks with this guy? What sucks on this guy? I don't have any rule about plus twice a log. So what can I do with this stupid thing to get it out the way? What property can get that 2 and move it somewhere else?
Natural y to the second power, right?
Yeah, I can take that back up. It would have been up in the exponent. That's how it came down. And now I can do the last step. Well, it's not the last step really, because let me do something in here first before I bring more shit in there. Can I do something in here? Anything?
Factor out x minus 1.
We'll factor out an x, and then the x
And
minus die. And then I can bring natural log of x. And then plus that means I'm gonna multiply. Woo! That was crazy. Love it. So it kind of makes more sense that math is gonna want to put these together. You will have some problems as they tear this apart, but more often in mathematics, we want to put things together.
Sir,
And
can
as
you go
we do
through
that,
that last? Sorry, right after you canceled out the x minus 1, you lost me.
oh, okay. Let me rewrite what I've got.
Yes, please.
You'll see it. So I got ln of x here, right? Plus ln of y squared. And of course, when I add logs, what do I do with the stuff?
Oh, you multiply them? Okay, got it. Thank you.
And of course, this is not necessary. This is not supposed to be automatic right now, but you should get better with this stuff. Hopefully I gave enough homework problems for this kind of stuff. And all of you are going to say, you gave plenty of homework everywhere, dude. All right, we'll see. Yeah, I think that's good. That's a good place. So that is 6-5. And hopefully in the next couple of days, I'll have that updated homework sheet done. We'll find out. We'll see. Otherwise, class is officially over. I almost don't want to post this considering half the class wasn't here, but oh well. I think I still will. Too nice. If anybody has questions, wants to hang out, let me know.
Thank you.
Professor,
Yes.
so I'm really sorry. You were doing 57 on 6.1 earlier, and I kind of got it, and then I kind of was looking at it, and I was like, still confused on it. Do you mind if we look at it one more time?
The annual percentage yield one.
Yeah.
Okay.
I was kind of confused on where they got the -1.
So listen. So if I put $10,000 into an account, right? And then at the end of the year, I now had $10,300. How much did I actually earn?
300.
Didn't you take the amount at the end of the year minus the principal, minus P? So that equation, this equation here, got this tells me the amount in my account at the end of a year. I'm going to go ahead and put 1 in for, there's normally a T there. I'm going to put a 1. So let's go ahead and put the 12 in. So this is the amount in the account at the end of a year if I compound monthly. So if I do this minus this, that is the amount I actually made.
Right. Okay.
And then the last step is to make it a percentage out of the original.
Okay.
Which, of course, how would you do that? You would just, so how would I do it with my 10,000 example? 10,000, 10,300. I made $300. Out of 10,000, I divide by the original. So I just have to take that and divide it by the original amount that I put in.
Right.
Which is
okay.
what, yes, and then you're there.
Okay.
Yeah.
Cool.
57,
Thank
you
you.
got to do the same thing with 365 instead of 12. It doesn't really change anything.
Okay.
Right.
Cool. Thank you so much.
You're welcome. Everybody
I
else
have
okay?
a question. No, I have a question. I was doing the homework, and I think it was 6.5. Yeah, 6.5. Oh, no, 5.4. And
Wait, 6.5?
no, 5.5. Sorry.
5.5, okay.
Yeah, and I was doing the division. What if you don't get like?
Which problem? Which problem?
Okay, number 18.
18, okay.
So I got the factor of x minus 3, and it like worked, but none of the other like possibilities that you do with the.
Oh, it doesn't matter. Because at that point, what's the degree of the leftover?
Squared. It's squared.
Yeah.
So it
And then
doesn't
you can
matter?
factor. You can just factor like normal.
Oh, okay.
It might not be factorable. Let me see. They want the real zeros. So if it's not factorable, you're gonna have to use quadratic formula, right?
Okay. All right. That makes sense.
Yeah. Okay, cool.
Okay. Thank you so much.
You're welcome.
It's more of a request. Is it okay to put the what you on the YouTube video titles? Like, say for example, if you go over 6.1, you just put 6.1 in the titles. I don't know if it's asking too much.
Well, I don't know. I think I started doing that, and then it's just I could do that. Yes.
I kind of get lost in your videos. That's why I'm asking. Yeah.
Yeah, it's harder to go back, especially if it's not that you missed a day. It's just that you want to review something, right?
Yeah.
If you missed
That's
a day,
what
it's easy for the day.
Yeah.
Yeah. All right. I'll try to be better. I haven't done that at all.
You don't have to do it. It's just a request. It's up to you.
No, it's a good idea. It's a good
Yeah.
idea.
Okay.
It's just when you have a meeting right after you're like trying to upload it, I sometimes don't even, I'm like, yeah, it's going. All right, shit. But I'll try to start doing it. It's not a bad
Okay,
idea.
perfect. Okay, thank you so much. Have a good day.
You too.
Later.
Brian, what's up? You good? Doug, you good?
Yeah, I'm just waiting. I was waiting for the other questions for like people have so I can like sort of see what's up.
Oh yeah.
Yeah, I was just kind of hanging around to hear what people ask. It's generally pretty helpful to hear what people are having a hard time with. So.
Oh yeah, I agree. Okay, good. I just want to make sure you guys are good.
Yep, that's it for me. See you.
Head out.
Later.
See you guys.